So there are three main components of the pit. There's a firebox, a control box, and a cook box. Firebox lifts off the pit, which makes it easy to clean. There's a removable charcoal tray in the firebox, so you build your fire on top of this tray. At the end of a cook, you empty it just by popping this tray out and dumping the ash out. The firebox has a tailpiece right here where the hot gas is withdrawn, and that tailpiece just plugs right into a hole on the top of the cook box. Heat is drawn from the firebox whenever the cook box has a vacuum in it. And the vacuum in the cook box is driven by this control box. It lifts off also, and it does that to make it easy to store it inside because there's some motors in here that we'd rather not leave outside all the time. There's two fans. There's a convection fan and a draft fan. The convection fan fits in this opening and provides continuous circulation of gas from the upper top of the pit to the lower rear of the pit. And the draft fan takes a suction on this opening in the pit and discharges overboard. And so when the draft fan turns on, it's pulling air out of the cook box, blowing it overboard. That creates a slight vacuum in the cook box, which in turn draws hot gas from the firebox into the cook box, raising the temperature. The temperature is sensed by this bulb capillary, which is under the convection fan, so it gets good airflow for an accurate temperature measurement. And the thermostat and all is controlled by a knob, just like on your kitchen oven. Effective temperature range on this unit is anywhere from ambient to 300 degrees Fahrenheit. And this guy just drops in pretty easily, and lays down into position. So the cook box, and this is all stainless, has 12 different shelf positions. The shelves are identical in size to a hotel steam pan, so if you need to reheat something, you can do that in a steam pan, although that's a significant impediment to airflow and can have unpredictable consequences on how fast different items are cooking. The theoretical capacity of this is about 60 pounds, so you could do 4 15-pound briskets, 8 7.5-pound pork butts, 12 5-pound chickens. You can get to 60 pounds a lot of different ways. If you're going to stuff it with 60 pounds of cold meat, you will have to rotate shelves because there's just such a cold mass there that the cooking will be uneven until everything starts to warm up. In my experience, anything up to about 30 pounds, as long as there's plenty of airspace for air to move around, it's pretty uniform. Certainly better than on a typical horizontal offset pit. You can see in the back that there is a mixing tube in the rear with some louvers, and that mixing tube mixes together this recirculating airflow from the convection fan with the hot gas coming from the firebox before it comes in contact with the meat. So that knocks down hot spots by a significant amount, just a little bit of pre-blending before it gets in contact with the meat. And in a nutshell, that's it. So what you can see this in action here. We've got a fire in the firebox. We're putting logs on top, so these are any old logs. Probably the smallest size you want to work with is maybe the size of a Red Bull can, and the biggest is maybe the size of a brick. They don't have to be bone dry. If they've been sitting out for 3 to 6 months, that's probably dry enough. They will dry out as they work their way down vertically. Gas is being withdrawn from underneath the coal grate as the thermometer cycles on and off. And so we can actually get in here. I'll collapse the fire a little bit and you'll be able to see, try to get a flame, a visible flame that you can see. You can actually see the flame being pulled vertically downward. It's inverting the flame. And that means that all that smoke that's generated by the combustion of those logs, by the heating of those logs, is being pulled down through that hotbed of coals. It's heat and a source of ignition for that smoke, and those air vents on the side guarantee that there's always a ton of oxygen available at the coal grate to get a very clean combustion process. And so the discharge from this is actually right here, and it's clear. So this is the holy grail of the barbecue community, is you want to maintain that clear or thin blue smoke, which is indicative of a clean combustion process. And It is a clean combustion process. And it will definitely cool off. This the draft fan right here will kick on any minute because this cold air is getting sucked right into the convection fan and cooling off that capillary bulb. So any minute here we should see our draft fan trip on, and it's sucking, right? It's trying to pull some more heat to recover the temperature in the pit, and there it goes. And so we've cooled down pretty good, and it should recover in about 30 seconds from when I close this. It's important for the Cookbox to maintain its air seal instead of sucking hot air in from the Firebox. And so this seal is pretty carefully constructed around the perimeter. It's not 100% airtight, but you wouldn't want to snake a temperature probe, for example, through here. That's just going to cause problems. So